Okay, we are recording. We are ready to roll. So, just a few announcements before we get started. So we are approaching the end of the semester. We have one more class with speakers officially. That's next week, and that's focused on environmental justice. And then, if you recall, after Thanksgiving, after Thanksgiving, we have 2 additional classes, which are both mandatory to attend. So make sure, you don't have conflicting things with those 2 classes. And then there is a Water Scholar Award. The applications are now open. Deadline is January 31st. It's an annual award that gives funding to researchers whose work on Western water would benefit from access to there's a water resources archive at CSU libraries, which is very unique. And it's a really cool resource. So if you need to do research and include their resources in that archive, they'll actually give you funding to access the resource, to go to present your research at conferences that you've incorporated those resources into your research. So if that interests you, take one of these little flyers and there's more information online. And I think that's all my announcements. Any questions before I introduce our speakers? Okay, and don't forget, Water in the West is happening tomorrow at CSU SPR. There's like a reception in the evening, and then the full agenda is actually on Thursday. Okay, well, I'm very excited to introduce my 2 speakers today. So our focus of our talks today for class is really on climate change impacts on water resources. And we have Esther Vincent from Northern Water. She completed her master's degree in civil engineering in 1999 from Grenoble Institute of Technology in France. She is a registered professional engineer in Colorado and has been with Northern Water since 1999. She has experience with water quality, watershed management, water supply planning, environmental permitting and regulations, and water conservation. And recently, she's been leading Northern Water's post-fire watershed restoration efforts in the wake of the 2020 East Troublesome Fire. She oversees Northern Water's water quality, water efficiency, and flow monitoring programs, environmental planning and compliance, and environmental data management systems. She has served on the boards of the Grand County Water Information Network and the Big Thompson Watershed Forum and Colorado Waterwise Council, and is an alumna of the WECO, the Water Education Colorado Water Leaders Program. For the interest of time, I'm going to skip to our second speaker. So Taylor Winchell, is that right? Yeah. He works on climate change adaptation and water supply planning at Denver Water, where he focuses on translating climate change threats to on-the-ground adaptation efforts. Taylor has additionally worked in the environmental nonprofit sector and on water-focused international development projects. He received his master's in water resource engineering from the University of Colorado Boulder and his bachelor's of science in environmental engineering science from the University of California, Berkeley. So let's welcome, first we're gonna have Esther Vincent speak, but another note, if you hear things in these speakers' bios that are of interest to you for your career, talk with them afterwards. And I know a lot of you are on the path to graduation, so connect with them and see, if they have opportunities at their organization. Okay, go ahead, Esther.
Thanks, Karen. All right. So it sounds like the next presentation you're going to hear is going to be a little bit more of a bird's eye view of climate adaptation. And what I'm going to do here is a little bit more focused on one particular aspect in the ways that climate change is impacting water supplies here in northern Colorado and in much of the western U.S. And it has to do with wildfires. Okay, it's. Yeah, it moved.
You got it.
Yeah. So just and I think I understand Karen told me that you had our general manager from Northern Water talk to your class before, so you've got some understanding of the Colorado Big Thompson project. But we serve over 1 million people, so that means that these watersheds that burn that I'm going to talk about are really critical for a lot of people that live on the Front Range. The ownership of the project in the past has been primarily agriculture, but it has over time shifted towards municipalities. And now we have about 70% of our project shares and units that are in the hands of municipalities. So treatment and quality of the water is important to them. And we, on average, deliver about 210,000 acre feet per year through the system. This is an overview of our collection system on the west slope, which I'll talk about in a minute. And on the other side of the continental divide is our distribution system, which takes the water that is collected from the headwaters of the Colorado River to the northern Colorado Front Range through a system of canals and pipelines that eventually bring the water into terminal reservoirs in Horsetooth and Carter Lake, and then from there it gets delivered to the end users. We do not treat the water. We're a raw water supplier, but because of what I said and that our constituency is primarily municipal at this point, water quality has become heavy focus, and treatability is important. A little bit of context for this conversation. So since we're talking about climate change, I don't think I'm going to be saying anything quite novel to any of you in the room. We've been seeing temperatures rising globally, and here in Colorado, on average, this is what it looked like if you go back to a time series all the way to 1895. It's pretty self-explanatory, and with warmer temperatures, a lot of things are to be expected. It means earlier springs, earlier snowmelt, and runoff, which also means a longer growing season, more frequent and severe heat waves, and hotter summers. Generally speaking, even if you have no change in precipitation, you still have greater evapotranspiration, which causes a net water budget deficit and a longer fire season. And we certainly have seen that, play out more and more so every year that passes. And then you overlay that on top of forests that are not and have not been healthy. We, in this area in the Rocky Mountain region, have been affected by an extensive mountain pine beetle kill that has left in some watersheds almost the entire forest, like 90%, sometimes even close to 100% of the forest that is dead trees. And these dead trees can stay on the landscape for a really long time. So when you combine that with the warming temperatures, it's a recipe for devastating outcomes. This is a chart that shows the extent of wildfires in the United States going back to the 1980s. And what's notable here is not just the greater frequency of fires, but it's the scale of these fires, and not just in Colorado, but in the Western United States. And we've entered an era of what we're calling mega fires that are burning hundreds of thousands of acres. In some instances, it's millions of acres in other states. And it changes the conversation about the impact of these fires and how you recover from them. So specifically in Colorado here, we're looking at the largest wildfires that were recorded. And you can see that they're all in the 2000s, and that 4 of the largest wildfires occurred in 2020. And again, there's a change in scale in the size of these fires. The previously largest fire was the Hayman fire in 2002, which was a very large fire and very devastating fire, which is still impacting the Denver water system today. But it's almost been dwarfed by the fires that we saw in 2020, especially when you accumulate the acreage burned between all of these fires. All right, so as a trans-mountain diverter, our geographic reach is quite broad, and it extends from the Utah state line on the west side to the Nebraska state line to the east side. And the CBT project straddles the Continental Divide, moving water from the headwaters of the Colorado River to northeast Colorado via the Adams Tunnel, which is 13 miles long. And our service area here is shown in beige. It's a little bit hard to see on the picture, but it's on the east side. The 2020 wildfires affected both sides of the Continental Divide, but nonetheless, the most impactful fire from the perspective of the CBT project is the East Troublesome Fire, which burned most of the major watersheds upstream of our collection system. The Cameron Peak Fire reached into the Big Thompson River watershed, from where we have the ability to divert water. So there's some impacts that we're seeing in terms of water that can enter our system there as well. However, because our diversion structure is located on the river in the Big Thompson, we have the option to bypass the water and not take it when it's fire impacted. It's not the same is not true for of the East Troublesome Fire. We have no way of passing the runoff from the fire, and it all comes into our system directly, which is Granby, Shadow Mountain, Grand Lake, as well as Willow Creek Reservoir, and then Windy Gap Reservoir, which is a little bit further downstream on the Colorado River. So this is the Cameron Peak Fire footprint, generally speaking. So this was, if we had done a desktop exercise of, what's the nightmare scenario, we probably wouldn't have come up with something this bad, but it happened. And this is what it looked like in the Kawanichi Valley, which is, if you go through Rocky Mountain National Park right before you go into Grand Lake, this is where it is. Burnt about a third of that watershed that flows into Shadow Mountain Reservoir. That was just days after the fire. These are additional aerial pictures that provide a view of the East Troublesome Fire. And on the right side, you can see from left to right, Grand Lake and Shadow Mountain Reservoir. And in the distance, you can see Granby Reservoir and the extent of the devastation upstream of these critical water bodies. And here's the scale of the fire. The fire traveled 20 miles the night of October 22nd. It burnt over 100,000 acres in that one night. Much of that growth happened over a 90-minute period, during which the fire made a 17-mile run and was pushed by hurricane force winds. So something to remember when we're talking about climate change and fires, we talk a lot about the heat, the temperature, the fuel. We don't often talk enough about the wind component. And I think you will think of probably many examples in recent history that led to extremely devastating fires because of the wind component. That was the case for Cameron Peak. That was the case for East Charleston. That was the case for Marshall, and that was the case in Hawaii recently. So 500, almost 600 structures were burned and 4,000 residents were evacuated over, I think, just a couple of hours. It's pretty miraculous that there were not more casualties. 2 people did pass away in the fire, but it's because they refused to evacuate, not because they couldn't. The fire burned in the end 193,000 acres, spanning 37 miles east to west, jumped over the Continental Divide. You'd think that it'd be a natural fire barrier, but there was so much wind that it blew embers over the Continental Divide, and it started burning and threatening the town of Estes. There was some real fear that the town of Estes was going to go up into flames that night. And burn severity is the keystone of all assessment and modeling efforts, and that's what you see on this map. The different colors represent the different degrees of burn severity. Something to note here is that the burn was primarily on federal lands, mostly Forest Service, some of BLM, and Rocky Mountain National Park. Only 10% of the burn was on private lands. The same statistics are about true for the Cameron Peak Fire as well. And that has a bearing on what you can do after the fire. So why do we care? Because in the wake of a fire, you tend to see pretty acute water quality impacts. You no longer have vegetation intercepting, rain or precipitation from the sky. You no longer have ground cover that absorbs or buffers the impact of that water onto the ground. And in some areas where the soils become hydrophobic, and what that means is that the soils have essentially melted and they form this almost plastic-like sheet on top of the surface, where the water can no longer penetrate and infiltrate through the ground. It just runs off. So it creates a very flashy hydrological response of the watershed, which then creates a lot of energy with that water being concentrated, moving really fast, increasing the volumes of water that you can see moving from even really small drainages. And as that cycle starts, it creates erosion. It entrains a lot of debris of various sizes, including really large debris, into the waterways downstream. And eventually all of that ends up, causing damage to infrastructure, causing flooding, and you see some significant changes in water quality. Initially, you'll see a really strong ash response that tends to lead to black water events, but over a longer term, even when that dissipates, you'll still see very significant inputs of nutrients in particular, and that has its own set of water quality consequences that come with it. I'll talk about that. So that's just an illustration of that process in the wake of a fire. And this is what we saw after these troublesome fire. We were told when we started talking to folks about what we were to expect, that we were going to see debris flows, flooding, water treatment tank shutoffs, loss of storage capacity, algae blooms, harmful algae blooms, loss of property, frequent road closures, and we saw all of that. And some of it was really tragic. This is from the Cameron Peak fire. There was a flood, the Black Hall flood, a couple summers ago that led to the death of several people and really significant devastation of property. Flooding and road closures, that was a regular occurrence on Highway 125 along Willow Creek, which was extremely burned. 90% of the watershed burned there. And that was almost a weekly occurrence 2 summers ago. Not so much this past summer. It's starting to get a little bit better. This is a picture of an event that happened this year. It was a big road washout on Forest Service land, completely took out the road. The culverts were undersized. They started clogging up. And pretty soon, because the water had nowhere to go, it started overtopping the road, and very quickly, and this happened in May or June, we had a rain on snow event and the road was gone. Huge gap. We just finished the repairs on this project just a couple of weeks ago. Lots of debris flows. You can see on the right side, some images of the deltas. Closures of the road on a regular basis. We saw degraded water quality even during spring runoff, even without the rains, just from the pulses of snowmelt. We saw extremely degraded turbidity events on a regular basis in Willow Creek Reservoir. We're still seeing that, even if to a lesser extent. For perspective, this shows at different depths in the reservoir the turbidity that's measured continuously. And the 100 NTU, this is typically what water treatment plants, that's their threshold for treating water. So anything above that, they have to shut off their intakes. So you can see how far above we were that. So there's no direct treatment plant intake on Willow Creek Reservoir, but there's hot sulfur downstream, and eventually that water moves all the way to the east slope. And so there were concerns about how much of that turbidity impact over time might move over to the other side of the continental divide. Certainly not with this level of acuteness, but they're still concerned about potential degradation of water quality over time. Black water events. This was right after a rain event on the west slope. The North Inlet is a tributary that flows into Grand Lake directly, right next to the town of Grand Lake, and it was just black water like this. These are samples that were taken by happenstance the next day. We were out there sampling. And the beach in the town of Grand Lake looked like this in the day after. Willow Creek Reservoir, because of all the inputs of nutrients that I was talking about, has been experiencing for 3 years now harmful algae blooms, and that has led to the closure of the reservoir to contact recreation at times, because we have had hits of cyanotoxins, which can occur when you have a harmful algae bloom. We get a lot of debris. We've installed debris booms to capture this on the system so that it can be removed in places where it is accessible, and we can protect key features of our facilities. And then we've seen a lot of sedimentation in that same reservoir. This is on the upstream end of the reservoir where Willow Creek comes into the reservoir. The delta has formed and expanded significantly, leading to some loss of storage capacity of about, for now, we think it's about 1% of active storage annually. So it doesn't sound like much, but if it keeps happening year after year, it could lead to something that's more significant. We haven't decided yet whether we're going to need to dredge, but we're keeping an eye on this and continuing to survey the reservoir to see which trend we're seeing in that deposition. So we've moved into restoration and protection pretty quickly after the fire. We've done a lot of work in collaboration with the Forest Service and with the NRCS. The first phase of it was on private lands because, long story short, this is where it was easiest to get funding for the work. So we did a lot of hardening of stream banks to minimize erosion, hill slope stabilization, installed debris booms to try to protect infrastructure. We set up a self-service station for folks to pick up sandbags to protect themselves from potential flood on their properties. And then we conducted extensive aerial mulching operations, which covered about 12,000 acres over a couple of summers. It cost us about $26 million. And when I say us, meaning this is funding from the federal government that was funneled through the Forest Service, as well as from the NRCS and from the state, from CWCB. We had to come up with match funding to make that happen. Over 19,000 helicopter drops to do this work. And it sounds like a lot, and it was almost 90 days of work, over a couple of summer, but it's 12,000 acres out of 193,000 acres that we were able to treat. So some thoughts about preparing for the future and strategies that we're really considering and advancing to be prepared, because it's going to happen again. No matter how good we get at forest health and treating the forest ahead of time, removing the fuel, we're talking about millions of acres of forest that are going to have to be managed to some degree. It's going to take decades to make that happen. It's going to take resources that are not currently available. It's going to take workforce. It's going to take people wanting to do this work and getting trained and skilled for it, which is not there right now. It's going to require some social infrastructure development because the Forest Service can't on their own with their staff go and treat millions of acres. So it's going to take partnerships and working between across jurisdictions with local partners and federal agencies and state agencies together. So a lot of relationship building, which you have to make it part of your business model, basically. I mean, you can't just wait until these events happen. You have to create these relationships right off the bat and nurture them even when you're not in the middle of an event or event response. It's going to require a lot of funding and capacity, but also talking about how to work with the private sector to create wood products and timber products where we can have a way to create an income stream that supplements the local funding and state sources so that we can treat large acreage. It's going to mean also preparing for scarcity, because you can see in this example that both sides of the continental divide were affected. So if you were a city of Fort Collins, for example, and your two water supplies are the Colorado Thompson Project and the Poudre River, both of these water supplies were affected at the same time. So it's preparing for that and creating resilience, educating your public if you're going to have shortages or cutting back on your water use, and diversifying your water supply portfolio, and getting really good at post-fire restoration, because as I said, as good as we get on the forest health management, it's still going to burn. And the higher parts of our watershed, the lodgepole pine forest, you can't do prescribed burn on this forest, and it's going to be really limited, the actions that can be taken on the ground to prepare the forest for this. So that's what I've got, and I'll wrap it up.
You mentioned that there's a need for a sensible amount of resources. Is there talk at all about creating a fund from tourism across the rising climate and rising temperatures, like the oil and gas companies in Colorado? Is there any collaboration with those companies to pay into a fund to manage these forests, and maybe why?
No, I mean, it's not. I mean, that's like, I guess that's a question that's above my pay grade in a way. But no, it's not. I just attended a forest wildfire summit in Denver this past week, and that was not where the conversation was going. Where it was going was what I mentioned, was really involving the private industry and trying to create a pipeline of funding and products. It's like, what are we going to do with this wood that has to be removed from the forest? Try to move it towards affordable housing, towards gasification and technologies that are carbon negative, work with the timber industry to create wood products that then will create a market that injects funding that allows you to do these projects. So there is federal funding that's available right now from the IRA and the bill funding that passed in the last couple of years. But that's gonna, that's not gonna last forever, and the need is gonna be there for a really long time. So we need to find like some sustainable ways of supporting this incredibly critical work that if it doesn't get done, our societies are really going to suffer very severely in the Western US. So, but it's not, what I'm hearing is not turning towards the carbon emitters, to have them pay for the work that needs to be done. So the question is about the role of prescribed burns in forest management. It absolutely is a tool, and the Forest Service is actively engaged in expanding the use of that tool. There are limitations to what you can do there. First of all, some prescribed burns, can go out of control. So they have to be extremely careful about when they do it. It has to be permitted. You have to work across boundaries too, because they're trying to create a ribbon along the Front Range that will create a fire break, basically, between for fires like these fires that have moved typically from west to east. But you can't use this tool on Ponderosa, on lodgepole pine forest, which much of our higher watersheds, which are our source water supply watersheds, are lodgepole pine forests. The Ponderosa pine forest, which is at lower elevation, which you kind of see in the foothills here, that's where the prescribed burn strategy is more appropriate and feasible, but it won't be a tool for everywhere in the watersheds.
And then that was really interesting what you said about wind. Do you happen to know what the climate projection is saying about wind speeds in Colorado?
That's a really good question. I'm sure there's some data and some information about it. I haven't heard it talked about very much. We talk about temperature, we talk about precipitation, but we don't talk about wind as much. So I actually would like to see more of that. Anecdotally, it sure feels like it's getting windier and windier, but I don't really know what the science says about that.
Let's take one more while I get the next presentation pulled up here. Any other questions for Esther?
Going back and just commercially taking trees and turning them into a product.
Yep. Yeah, that's exactly what I was getting at when I was talking about working with the private industry and creating wood products that will create a funding pipeline for doing this kind of work. So it was very encouraging at that wildfire summit that I attended, because the private industry was very present. They were invited there, and they spoke very knowledgeably about other parts of the U.S. in Oregon in particular, where they're doing some of that, and they're creating templates for working together to make the forest healthier and do this kind of work. They did talk about hurdles that they are running into in terms of what they called the Lorax effect, that we've gotten so good as a society at telling people that we shouldn't cut trees as a reaction to a different time and age of timber industry, that local communities in some areas tend to be very resistant to this conversation. Okay. Taylor, let me see if you want to use.
All right, hi everybody, and hi online world. So I'm Taylor Winchell. I work on climate change adaptation and water supply planning at Denver Water, and just gonna speak a little bit to implications of climate change for a water utility, some ways we approach that, and yeah, happy to take any questions at the end. So Denver Water was established in 1918. So about 105 years old now, and it was established then through the combining of multiple water companies that had sort of formed in tandem to serve the city of Denver at the time. Today we serve about 1.5 million people using about less than 2% of the water used in Colorado. And so we are a freshwater supply utility. We don't do wastewater, things of that sort. And a little difference between Northern Water and Denver Water is so we both do wholesale water, so kind of selling raw water to other utilities, as well as we have our own treatment plants and treat the water and deliver it to our customers, and then maintain our distribution system of pipes and mains and all that good stuff. And so our water supply comes from snowmelt and rain, feeding both South Platte and Colorado rivers. And our collection system covers about 4,000 square miles of watershed area. And then to do all this takes a lot of infrastructure. So we have about 3,000 miles of pipes, 3 potable water treatment plants, 1 non-potable reuse plant, 12 reservoirs, and 20 dams. So this is what our collection system looks like. So the red outline on the right side of that map there is our service area. So that's where we serve customers water. And then the highlighted polygons in the watershed there are where we collect water from. And then so the red dotted line is the Continental Divide. About 50% of our water comes from the Colorado River Basin, and that's brought to the Front Range or the Eastern Slope through Trans-Mountain Diversion tunnels. The largest tunnel being the Roberts Tunnel, which goes from Lake Dillon or Dillon Reservoir and outputs in the North Fork of the South Platte River. Let's see, does this have? Yep, so it goes about right here, and then outlets in the North Fork. That's actually 23-mile long tunnel that was built in the 60s, and I think at the time it was the longest underground tunnel in the world. So just pretty fascinating engineering. And then we also collect from the Fraser Basin up here. And so we kind of have this south system, we refer to it as, and then the north system. And the majority of our water is collected in the south system. And so here's the headwaters of the South Platte River, comes through a few reservoirs here, down through, and then of course it continues out to Nebraska and eventually to the Mississippi River. And I also represent Denver Water on the Water Utility Climate Alliance, which is a collective of 12 utilities from around the country that work together to advance climate adaptation in the water sector. It formed in about 2008, really in recognition that water utilities are sort of on the front lines of climate change impacts. And that there was just so much information and new science coming out, and it would benefit the entire water sector to kind of work together to advance climate adaptation. So that's kind of feeds into what will be talked about in my talk as well. So for Denver Water, we had some wake-up calls for what climate change would really mean for us as a water utility, kind of starting in the mid-90s. So we had the Buffalo Creek fire, which is that outline right there. And then in 2002, we had the Hayman fire, which is this large outline, which until 2020 was the largest wildfire in recorded history in Colorado. And then in 2020, it was surpassed by 3 other fires and almost by a 4th. And that water body right there is Cheeseman Reservoir, which is a primary reservoir in our system. And so the fire burned entirely around Cheeseman Reservoir. And then also in 2002, there was a 2002, 2003-ish, there was a very intense drought, which depending on kind of how you measure drought was, the most intense or one of the most intense droughts in, again, recorded Colorado history. So all these were kind of wake-up calls. And then, so this came after the Buffalo Creek fire in 1996. There was like a 1.5-inch rainstorm, not about a month and a half after the wildfire. And this is in one of our reservoirs, Taronja Springs Reservoir. That's the dam infrastructure there. And all this debris washed off, and it almost shut down our entire system, or our entire south system there, where the majority of our supply comes through. So, real threats that we're dealing with and trying to mitigate against moving forward. And then this is Cheeseman Reservoir here, and you can still see the impacts of the wildfire today. I don't know if anyone here studies wildfire, but that fire just burned so hot and intense. I know a lot of folks study it in Colorado, that we just haven't had much regrowth there even 21 years later. And so the way we've kind of evolved to think about how climate change impacts water utilities, and again, a lot of this comes from sort of how thinking has developed through that Water Utility Climate Alliance, is really that climate change impacts all utility business functions. And, really you can, I think, replace utility there with just any business, anywhere, any industry in general. And so just going through some of this here, so we have our water resources, potential wide variety of impacts, whether it's through increased evapotranspiration, changes to precipitation patterns through the wide array of precip patterns that feed us here in Colorado, from the jet stream, the monsoon from the Gulf of Mexico, our convection storms here on the Front Range, and then of course impacts to the snowpack, which is the primary source of where our water comes from, and which is directly impacted by temperature. And then people, so as a full service water utility, about 40% of our staff works outdoors on a near daily basis. So, ensuring that our staff are prepared for heat waves that they've never seen before, and can mitigate that. And we're really taking care of employee health and safety, customer demand. So on any given day in the summer at the municipal level, the two biggest impacts on how much water your customers use is going to be what the weather is, or how hot it is on that day, and then if it's raining or not on that day. Because if it's raining and it's cold, people probably aren't going to be using much water, and vice versa. And so as both of those things get impacted by climate change, it can have impacts on customer demands in a variety of ways. And then also climate change impacts social values around how people use water. And then employee recruitment, and just really kind of leveraging that, hey, we're a climate forward organization, and folks entering the workforce today are likely going to be more interested to work for an organization that's taking this seriously. And then engineering and asset management. So of course, as I talked about, we manage this huge system of assets and design new engineering projects. And we refer to like the watersheds where our water comes from as our natural assets. One example I always point to here is from the Tarrant Regional Water District in Texas, which serves the Dallas-Fort Worth area. And they had a pump that pumped water through their system that was cooled by water in their reservoir. And that reservoir water got so hot, it got above 90 degrees Fahrenheit, and the pump actually failed because the water could no longer cool the pump. So they've had to replace that with the air-cooled pump. So really factoring in these types of impacts to assets and again, how we manage them. Water quality and treatment, Esther covered this extremely well, but again, that's that picture from after the Buffalo Creek fire. And then of course we have impacts from algae blooms. As drought lowers water supplies, this can increase the concentration of pollutants that need to be treated out of the water. And so, yeah, wide variety of impacts, water quality and treatment. Supply chains. So even though, we're in Denver, far from the ocean, even though this used to be covered by the ocean long time ago, we are impacted by impacts to the global supply chain because we source materials from different countries around the world. And these materials generally come in through ports. So when there's sea level rise, storm surges, this can throw off supply chains that we need to maintain our system. And then all this kind of feeds into finances. So variable weather can lead to large revenue swings in how we maintain our business operations. What I always say is we're not in the business of making a profit, but we're in the business of staying in business. It takes money to maintain and build a water system and to pay employees that do that work. And so it's really hard if your revenue is has large swings from year to year. Bond ratings. So we have a bond rating that's given by agencies like Moody's, S&P, because we issue bonds to the market to fund some of our infrastructure development. And I was just on a work group meeting organized through the EPA earlier today with rating agencies, because these rating agencies, they're really taking climate change into their consideration now and how they're rating bond issuers. And if you're not disclosing to them, one, what your climate change risks are, and two, what you're doing to prepare for those, it will negatively impact your bond rating, which then means that the money that you borrow has higher interest rates, so that negatively impacts your finances. And then insurance. If you're interested in a market that wants to hire a lot of people who understand climate change, probably insurance. They're going through some major growing pains right now because, as you know, you've probably heard and seen and maybe have studied, that they just can't keep up with the devastation of climate change and are really trying to figure out what to do. So some strategies and approaches of kind of how we take all this and think about, you know, okay, as a water utility, how do we integrate this into our practices and into the utility as a whole. So I'll go through some general kind of topic areas, but it all kind of falls under this umbrella of kind of what we refer to as like climate adaptation mainstreaming. So really like mainstreaming climate adaptation principles into the entire organization, so that anyone working is thinking about climate change and coming up with adaptation solutions in whatever subject that they happen to be an expert in. So some of the ways we go about this is one, just fostering a climate-informed organization. So, you know, giving actually like similar talks to what I'm talking about here. We have a new employee orientation every 2 weeks. We have about 1,100 employees, so there's a pretty constant stream of people coming in and out. And so at every one of those orientations, we give an overview of what climate change is, what it means for a water utility, and then we have various meetings with different work groups throughout the organization as well. Long-range planning, so it's sort of embedded into the culture of Denver Water and really any water utility in Colorado and the Western US to be planning long range into the future. And so that's, you know, it's why the cities here along the Front Range exists, because decades and decades ago, 100+ years ago, people secured the water rights to support those cities. And so ensuring that we're maintaining that long range view and through a climate lens. And then all this leads into, you know, what Esther was speaking to as well, diversifying our water supply portfolio, and then also just our raw water management operations. So how we move water around our system, how we plan from day to day, week to week, year to year, and becoming more flexible and more nimble to adapt to changing conditions and conditions that are no longer stationary from what we've seen in the past and what a lot of decisions in terms of raw water management operations have been made off of. And then, you know, supporting and encouraging climate adaptive projects and programs throughout the utility. So we have a program called the From Forest to Faucets program, which is a watershed management or wildfire mitigation program that started after those wildfires. So it's interesting to see the 26 million spent by Northern Water on the mulching. You know, it's estimated that in the years following those two fires that I spoke to, we spent about 27 million just recovering from those and getting sediment out of our reservoirs and kind of mitigating the impacts of that. So we realized that it would be more beneficial to spend money up front to reduce the severity of these wildfires that we know are a natural part of these systems that we live in, but that have just gotten to a scale that we've never seen before. So we spend a lot of money on forest treatments, post-fire work, a lot of clearing, fuels reductions, and I think more recently some prescribed fire has had a more of a been more kind of accepted in the fire management community in Colorado in recent years. And then developing effective decision support tools and really kind of maintaining a beat on what tools are emerging, you know, whether it's from local and state government, federal government, from private companies, and evaluating how those might fit into the operations that we do as a water utility. And then facilitating important internal collaborations. And Esther really spoke to this as well. Like, I don't know, this has become kind of my like focus really lately, and just realizing how important it really is, and how much you can improve it at any organization. We had an event earlier this May where there was a very intense rainstorm in our watershed and in the South Platte watershed. And it's that we'd never seen before of this kind of scale. And it really reduced the salinity of the water coming into our treatment plants, which sounds like not a bad thing, but it actually has implications for the corrosion of the pipes in your system. And so if the salinity is too low, you have to increase it. And this water came so fast that we had to change the sources of what water we were treating. And, you know, I heard someone who'd been at Denver Water for probably 30 plus years say that the only reason they were able to manage through this event was because of this new watershed management work group, actually, that's been around for a few years, that has like established these collaborations and networks already to just have the relationships and make the needed calls. So yeah, and then I'll just skip to partnering with the climate science research community. So, you know, it's really important to us to be able to understand new climate science that's coming out. We partner a lot both with the Colorado Climate Center and the Colorado Water Center, both here at CSU. So those relationships are really meaningful and valuable to us. I don't have too much time left, so I'll just kind of go through these pretty fast. But with the snowpack being such an important thing for our water supply, the majority of our water supply comes from the snowpack. We refer to it as our largest reservoir. It's really important to be able to measure that snowpack. So this is some data output from Airborne Snow Observatory's technology. You may or may not be familiar with this, but it uses LiDAR to measure the depth of snow across a watershed, and then uses density to convert that into snow water equivalent across the watershed. And then you actually get a value of the volume of water that's in that snowpack. And it really leverages on top of the existing SNOTEL network. So these 4 dots that you're seeing here, the 4 yellow dots, are the SNOTEL stations in this watershed. And that's what we've historically used to understand the snowpack. And you can see how much additional information that these newer technologies provide to us to then be able to make better management decisions. And this was actually last year or this year earlier, for the first time, we did a really cool thing where we flew. This is Lake Dillon Reservoir, and this is the Continental Divide. And we were able to fly Dillon Reservoir and then the Upper South Platte at the same time and really compare the snowpack across the Continental Divide. And that Roberts Tunnel again comes across or underneath the mountains there. So being able to understand those volumes is really vital to knowing how much water to leave in the Colorado River Basin or that we need to bring across to meet our needs. And then this is actually, I don't know if you've seen these, Esther, but this is from that LiDAR data, you first collect snow-free data. And so we were fortunate, actually, we had a snow-free data collection in the East Troublesome Fire Scar before the fire and then after. And so the green is sort of the canopy height, and then that's what it looks like after the fire. So again, that's after the fire. So all that canopy was lost from the fire. And then that's just change in height of the canopy. And then this is a snowpack measurement after the fire. So here's one around peak snowpack. And then this is as the snowpack's melting. And then one pretty interesting thing here. So again, that's before the fire, after the fire. And so you see this like green strip of forest here. So that didn't necessarily burn. And you can see as the snow melts out, that's where the snowpack maintains as it's melting out throughout the season. So pretty qualitative, but just a lot of interest. And anyone can actually go download and do research with this data. So if you're interested in snow, I highly suggest you to go check it out. I'm gonna skip that just in effort in looking at the time here and just thinking kind of high level, kind of what's seems to be needed for climate adaptation, both now and moving forward. One is change management training, and actually mentor kind of told me this, and I was asking her, like, you know, what she's worked in this field for a long time. And I said, you know, what still coming up in the field, like what would you recommend someone to do? And she said, get change management training, because that's really what we're talking about here, changing the culture of organizations, changing how we manage what we've managed for a long time historically. Again, collaboration and partnerships, leadership courage. So really, I think a lot of this, it's kind of, dual-sided, comes from the bottom and the top, but I think anyone in a leadership position at any sort of organization today really has to just at least ask the question, what does climate change mean for our organization, and how can we address that? Climate adaptation policies, whether, at the internal business level scale or at the government scale, really just good data for making good decisions. There's a lot of data out there. There's a lot of ways to analyze data. It doesn't mean it's all good. So really what we look for in the probably thousands of decisions we make every day as a water utility is good data that's provided in, an understandable, effective way. So I think this is a place where there's just a ton of opportunity to contribute to this field moving forward, and then lots of other things. So yeah, I think that's all I have, but happy to take any questions. Yes.
Does equity in water have lots of other things?
Yeah.
And also, people who are also prepared to deal with water.
Yeah, for sure. Thanks for bringing that up. And I skipped over this, but these are the planned projects for that Water Utility Climate Alliance group for this upcoming year. And we've actually been working on this project here, Advancing Water Equity and Climate Resilience, for the last 2 years. And are then going to be wrapping this up in the next year to really, kind of establish more of a framework and examples of how people are impacted differently from the impacts of climate change in the water sector at the water utility level, both at, from utility to utility, and then also within customer bases. So yes. Sorry, online, the question was, how does, whether, factoring in equity into climate change adaptation, is it how that's being considered moving forward? Yes, in the back.
Regions and areas with lots of snow. How does the lack of vegetation snow melt and the water
Yeah, it has many impacts kind of depending on how the fire plays out. So I mean, one is just let's see, so the dust on snow impact. So you have dust. Well, there's dust that comes a lot from the Arizona desert areas onto our snowpacks. But then when a fire burns, of course, you have the burned carbon. And so that can then get deposited onto your snowpack, and then that absorbs more sunlight, and your snowpack melts a lot faster. And then what Esther spoke to as well, the hydrophobic soils. So as snowpack melts, it just comes off a lot more rapid. So there's many impacts, and it's something we think about a lot. Yes.
Can you talk more about how you partner with research findings and
Yeah, and that's something that's really been spearheaded by people in the field before me. Is so we partner, like I said, with the Colorado Climate Center here at CSU, with Russ Schumacher and Becky Bollinger, and we actually worked together with them this year on there's actually something called the Climate Change in Colorado report, which the first one was released in I think 2008, and they're about to release the third iteration of that. And so we partner with them on that. A lot of it is kind of this co-production approach. So bringing the perspective of a water utility to people working on climate science research of here's kind of how information can be more helpful for us, or here's what we need to help make decisions. And then, vice versa. So, and then we also work a lot with the Western Water Assessment at CU Boulder. And Yeah, we're part of a work group called Hyperfacets, which is like a Department of Energy funded project that brings together climate science researchers from across the country, as well as like water management and resource management stakeholders. So um, um, yeah, it's something that we're always looking to expand upon, and we found it just super valuable to be able to ask questions directly to, and like when new science or new paper comes out, to just be like, I email like Russ and Becky a lot, just being like, hey, what's the deal with this? And, get some good feedback from them. So.
Any other questions for Taylor or Esther? I have a question kind of both you mentioned diversifying your water portfolio. I'm just kind of interested in how you guys do that, especially like in Charleston, where there's a lot of impacts to those headwaters.
So the question was about strategies that we're adopting to diversify our water portfolio. I would mention a couple of things in our case. One of them is the pursuit of Glade Reservoir. It is, like it or not, we live in those of us that live here in the Western U.S. We live here because of water storage. Water, as we talked about, comes through between April and July. And after that, it's gone. And if you don't have a place to put the water, you're kind of out of luck if you want to take a shower or grow your crops. So why it's important in this case is because it's on the other side of the continental divide, the Poudre watershed. If you look at the climate science and the predictions in terms of precipitation and temperature, they're different than, say, the lower Colorado River. It's going to get warmer, but the precipitation trends are a little bit different in the sense that we're going to see more highs and lows, but it's not necessarily looking like we're going to see an overall decrease in precipitation. So that matters because you're drawing water from very different watersheds in different parts of the Western United States and that are subject to different climate influences. The other one that I will mention is that there's a lot of ag in the South Platte Basin, in the Poudre Basin, and some of that, there's some real concerns about the buy and dry of agriculture and the loss of these water supplies and the migration of these water supplies to other watersheds, namely in the Denver metro area. So preserving the water that is already here on the landscape and within these watersheds and making sure that it stays here and doesn't go somewhere else is a really important part of that equation as well. I don't know if you
Yeah, you covered it really well. We're also currently undergoing an expansion of one of our reservoirs, and a variety of other strategies. Really, whatever. A lot of it in water, I think, is just creative solutions. So we've been piloting a technique called aquifer storage and recovery, which is like taking water in excess wet years and pumping it into underground aquifers and then pumping it out when you need it in dry years. It's not something that we're implementing at scale, but something we're just testing the feasibility of. So things along these lines.
Any other questions?